9.2.3, how can I find the side length? Understanding square root. So we need to understand how to find square roots because it's going to be the way that we find the missing side of right triangles. So we've developed a way to decide if a triangle is a right triangle by looking at the squares of the side lengths of the triangle. But if we already know a triangle is a right triangle, how can the Pythagorean theorem help us determine the length of a leg or of the hypotenuse if we don't know what it is already? So if you'll remember back here in these examples, we know what the squares are, but we need to understand how to find the square root of these three numbers to find out what the actual lengths are. So that's what we're going to do right now. We're looking at how to find square roots. So they've given us a whole bunch of numbers up here, and they have let us know that these numbers are all examples of perfect squares. So that's an important term to remember, a perfect square. So if each of these numbers represents the number of square units in a square, what is the side length of each square? So I've written out a square already for the first number, which is 36. And we know that 6 times 6 is equal to 36. So that is what the side length is for a square of area 36. So what about a square of area 34? All right, so if you remember your times tables really well, you'll be able to figure that out. But we've also included a times table for you on the handout on the last page. So you can look down this diagonal and find these perfect squares because 5 times 5 is 25 and so on all the way down the diagonal. So 14 times 14 is 196. So that's just to help you find these easily. So go ahead and find out what the rest of the square roots are of these perfect squares. All right, moving on to part B of 9-81. Why do you think these numbers are called perfect squares? So in the case of these perfect squares, you are simply taking whole numbers and multiplying them together and getting the perfect square. But what if you have a number like, say, 12? So if you're looking at 12, the factors of 12 are 1 times 12, 2 times 6, 3 times 4, 4 times 3. But I can't think of any number that we can multiply by itself to get to 12. And actually, that number is going to be somewhere between 3 and 4. So we don't know what that number is right now. So 12 is not a perfect square, but these numbers all are. And so a perfect square is the product of whole numbers.